Hello, this video I'm going to work on deriving a kind of ugly, it seems like a kind of ugly equation, but I think by the end of the video you'll see it's really not that bad if you just kind of look at it in parts. This is going to be the delta x equals VIT plus 1/2 AT squared, and it sounds like a lot at first, but really it kind of follows from what we figured out right here. So let me leave those up there. Now you'll see why I drew that barrier there. So let's start with kind of one of our more basic definitions. We've got the delta x, the distance that we travel, is equal to the average speed that we're traveling times however long we travel at that speed for, right? So we know that also that the average velocity is just that. It's the average of the ending and starting velocities. Bf plus bi. Sorry, bad handwriting. So it's the average of these two velocities. That's what the average velocity is. So if we plug this in for that, if we plug this in here, then we get delta x equals, so we're plugging in this, plugging this in here. So we get delta x equals Vf plus, actually I don't even need to do this because we already did this up in here, right? So actually I'm going to go here and I'm just going to erase that. We have this equation, right? So now what is our where am I? Aha. Okay. So we know that our delta x is equal to t, this t right here. I'm just kind of rearranging it, times Vf final velocity plus the initial velocity over 2, right? You're comfortable with that? The distance that you travel is equal to the time you spend traveling times the speed, the average speed you're traveling at. Hopefully that makes some sense. What next? Okay, and then we know here we have that the final, let me copy this over. We have that the final velocity is equal to the initial velocity plus acceleration times time. So what happens if we plug this Vf in up here? What happens if we plug in this equation? Let's make it red for now. No! Not what I want. Yellow. Yellow is always better. What happens if I plug in this right here? Right? Because it's just Vf, Vf. Should make sense. Well then, I'm going to try to color code it. Maybe that'll help make things clear. Then we get that delta x, or the change in x, is going to be equal to t times vi plus at. Oh wait, I meant to do that in another color. So let me erase that actually. How about I literally copy and paste it? Partly because I'm lazy and partly because it may help. So I'm going to copy and paste that here. See if I can make this smaller without making it look terrible. Didn't really work. Oh well. Vi plus at, right? Because that's just what this is right here. In that yellow box. Right? That's what this is. It's the same thing. Same thing. Same thing. Keeping it consistent. And then it's that. I'm actually going to copy and paste it so that way you can see where everything's coming from. Plus Vi and all that over 2, right? I gotta make this a little bit longer line. But you see where I'm coming from? We've got the delta x, t, t, vf, that's just this right here, we plugged it in, plus vi over 2. And then if we want to simplify like terms, then we get, well, vi plus vi 2 vi plus at over 2. And, oh, sounds like my mom's home. Be ready for an interruption. And then we can, how about we divide by t next? So we get t times, well, 2vi divided by 2 equals just vi plus at divided by 2. We can either say at over 2, or we could just say plus 1/2 at, right? I mean, it's the same thing, at over 2, 1/2 at, hopefully that makes sense. And now, we just kind of distribute out the t, we multiply there, and then we multiply there, and we end up with delta x, oh cool, right triangle, delta x equals vi t plus 1/2 a t squared. And what does this mean? Because I don't want you to just see the formula and memorize the formula, because I don't think that that's a good way to teach. Mr. Roscoe and apparently Dr. Martino and most physics teachers think that's a good way to teach, just memorize it. I don't. I want you to understand this. So the distance that you travel is, kind of look at it like this. This is how far you'd travel if you were just going at that initial speed, right? Because it's your initial speed, it's the initial speed that you're moving times however long you're moving for. That's how far you would travel if it weren't for the acceleration. And then this might not be quite so obvious, but basically you can think of it as a times t is how much you're changing your speed. So then that times time is you can kind of view this as let me put a little text box in. You can kind of view this as how far you go because of the change in velocity, right? Because this is how far you'd go if you weren't accelerating, and then this is kind of like that little bit extra. So hopefully that makes sense. Hopefully it's a bit clearer to you. Next video, I'm going to do the vf squared equals vi squared plus 2a delta x equation. That one's a pretty ugly one. It's mostly math and proofy. I haven't yet seen an intuitive way of explaining that one, so I'm sorry for that, but I'll see you then.